Hello and welcome everyone to UTA Planetarium's this week's live star stream. My name is Levent Kurdemir and here Jim Bader with me in the studio in the office, and we are here another news and updates from the night sky. So yeah, should we start with the night sky update? I think some people are waiting for night sky update because they asked us what's going on in the sky, and here is what's going on in the sky. So sunset is pretty late, right? So do you know the reason of the sunset being pretty late, Jim? Yes, because if you noticed, I can see stars in the sky almost like at 6:30 in the winter time, and now it's the summertime, especially in July. We just passed the summer solstice, but the summer solstice is the longest length for the day. All right, so let's take a look at the night sky. And the first, we'll start from south direction, right? Or you were going to show us some. Okay. All right, so let's start from here. Because when we look at the south direction, one of the very popular constellations actually in the sky you can see right away, and especially it is very easy to recognize this constellation from this little red star at the center. Well, this constellation, you can use your imagination. Well, these three stars over here and a curly tail like this. So does it look like something to you? Well, some people call it fish hook, and I agree. It looks like a fish hook, but also some says this looks like a scorpion because scorpions have curly tails like these. And the constellation Scorpius and the red star. This is a noticeably red star, and yeah, stars do appear in different colors. This is Antares. You also know that as the heart of Scorpion. Because Mars is the other red eye.
I love this story because of how convenient it is. But watching Mars get really close to Antares, which happens, it's super cool looking. Super cool to see these two very red objects right next to each other.
Well, you should never miss this constellation, and in the east, especially. Let's take a look at when you look at east direction. Let me get off the way. So you see a triangle, big triangle in the sky. So this triangle is called summer triangle. So what a simple name, right? Summer triangle. It is visible most of the time during summertime, and it's a triangle. But this triangle is not a constellation. There are three constellations on each part. So let's start with one part is the brightest part will be the star Deneb and the constellation Cygnus the Swan. There you go. Draw our triangle. And the one of the constellation, this is here is Deneb and the constellation Cygnus. You can see this like flying swan if you can imagine. This constellation is very famous because one of do you know the first discovered black hole and its name?
We call it Cygnus X1.
Cygnus X1. Yeah, the first black hole was spotted in this constellation, and it was named X1 because that was a strong X-ray radiation source in the sky. So the detectors, the radio telescopes, the X-ray telescopes detected strong X-ray signals from one spot in that constellation, and then they were wondering what that is, so they named it Cygnus X1 for that. Hello, Draco. It's not Draco. Draco is
I
in,
I think she was referring earlier to the curly
oh, the curly tail. Yeah,
tail. Yeah, I was trying to point that at just a moment.
yes, Lami, you're right. So it looks like Draco. We can talk about Draco. Draco is up in the sky between Ursa and Ursa Minor. When I talk about summer triangle, I always like talking about this star and this constellation right over here. So this star is called Vega. Vega is, we actually, if we grab Vega and put near the sun, they almost look like twins. So with all the properties, Vega is a brother or sister of twin brother or twin sister of the sun. But of course, the sun is very close and this star is far away. We don't get to see it as bright and as close. The Vega is in constellation Lyra, known as the harp, but a lot of people like calling it necktie. I agree. But here, for amateur astronomers, at the bottom of this constellation, there's an amazing object. That object is called Ring Nebula. So if we take a look, if we have big enough telescope, and which most amateurs have, then they can at star parties show that telescope, show that object to you at their telescope, and there's an object like this. So if you're wondering what that is, now we are looking at a dead star. Well, the stars do die. If you did not know that, bad news. The stars have limited lifetime, just like all of us, right?
This is
Of
easily my favorite like colored deep sky object. It is just so beautiful.
Yeah, and this one was the one of the first ones spotted in space, and because this the ring shape looked like a an orbit, so they called it a planetary nebula because they imagine like maybe there's a planet orbiting in this, and the nebula means actually dust. It's a Latin word for dust, so planetary dust. But it turns out actually this is a dead star. That means there was a star, and at the end of the lifetime, the star just, instead of exploding because it was not big enough to explode, it just pushed all the gas and dust away from its core, and it is still hot gas. It's cooling, and the colors also represent the temperature. Yeah, so we can tell the hottest gas is located inside because it's blue, and as we go to the edge, the gas gets cooler and cooler. It starts with, it's a good spectrum. The hot part getting the middle temperatures, and the cool part, which is red.
So this idea of stars that aren't massive enough, we say that they don't explode. They just expel their outer layers, right? And kind of fizz out. I mean, if you're pushing out this amount of mass, that distance, that's still kind of an explosion to me. It's just not quite as an explosion as a supernova, which is what people think of when they say explosion. Pretty interesting. Anyway, Lamia says, can it be considered like a supernova? And that's definitely kind of what I was asking. Do you want to elaborate on that a little bit, Levent?
This one?
Yeah.
No, this one is not considered a supernova because supernova is a big explosion. So this star was not massive enough because the stars needs to be 3 times or more massive to be able to explode. I said be able to, because what happens is at the end of life star, the stars, like pretty much anything else, they are on a force balance. So this balance is the stars produce energy. So let's say this is a star. At the center, the star is producing enormous amount of energy. And this energy pushes the star out because the energy is trying to escape. When energy is trying to escape, it is interacting with the inner molecules of the stars and pushes them outwards. Well, against this force, the gravity works, because the gravity tries to shrink the star. Well, stars are not solid objects. They are all gas, and they are trying to shrink the star to the core. So at the end of its normal lifetime, the stars are under balance of two force. So they are not expanding, they are not contracting. Well, when the energy production stops, there is nothing to fight against gravity anymore. So what happens then? If there is nothing against to fight the gravity, the star starts collapsing. So here is the problem starts. How much the star can collapse? So the gravity force never stops. It keeps pulling the star to the center, and the star is forced to squeeze and squish into pinpoint. Can that happen? Can you just shrink all the star stuff into one single point in space? Not possible, right? So because it's not possible, after some time, after some the pressure build up in the core cannot just take that anymore if the star is 3 times more massive to start with, and there was a big explosion because matter doesn't like to be in that state, and it explodes. This explosion is called supernova. It is followed by a big shock wave that spreads all the gas and the atoms and electrons of the star away in the universe. This is not the case here. This star, well, it pushed the gas slowly and happily in the vicinity, but the star is there and it is still collapsing and cooling. We call these kind of stars brown dwarfs because they can just remain as a solid object, a very compact object, and still cool down in the core of the star. Yes, enormous energy, then explosion, because again, the matter, regardless what, any matter, any like atom, molecule, doesn't like to be compressed too much, because they need room for electrons and protons to move freely in the atom.
Just an enormous explosion.
Enormous explosion, right?
Right.
And you know what? The supernova explosions can be visible in the night sky if there is one in our galaxy. So unfortunately, most of the supernova explosions that we observe are happening in different galaxies, and they are too far away to observe. But what happens is it doesn't happen in the immediately. Like one bright object appears in the sky and then gets brighter and brighter and brighter. That's actually why it's called supernova. Now the super comes from the magnitude of the explosion, but the nova means new. So new thing in the sky, new star appears in the sky, and it gets brighter and brighter. In the oldest history we can track, in the nearly year 1000, Chinese observers reported the first supernova. You know that? And the Kepler was the luckiest astronomer because he observed 2 supernovas in his life.
Not to push, but Kepler also was extremely lucky in that he was able to gather all of Tycho Brahe's work.
Yes.
Now it's called Kepler's law, not Tycho.
Well, he developed the theory. Let's not go into that object because it's controversial.
Yeah, it's slightly scientifically political, maybe.
Yes. Do you know when was the last observable visible supernova in the night sky?
I do not.
It's called 1987A.
Oh, yeah.
Because it happened in 1987, and since then it didn't happen. And statistically, the visible supernovas happen 1 in a century. That's why Kepler was lucky, because he had seen 2, but statistically 1 in a century. So the next one is going to be happen sometime before 2087, which is a long time.
Oof, that ways.
The Betelgeuse, we can maybe talk about Betelgeuse later because it's a supernova candidate. If anything happens, any supernova happens in the sky, that may be Betelgeuse. All right, so we I think just diverged from the night sky view, right? Like we do all the time. Anyway, the last thing I would like to show you, not the least thing at least, here is right now we are looking at north direction. It is a wonderful time to spot this big constellation right here. 7 bright stars look like a spoon or just a handle and the spoon. This is called Big Dipper or Ursa Major, which means big bear. So the bear is the different story, but the handle over here points another star, which I will show you in a few minutes. But I would like to talk about this edge part. So this edge part points us a very special star in the sky. If we draw a line like this from here to the edge stars, I like calling them guide stars because they like me or they let me to allow star hopping. What is star hopping? Hop from one star to another. So if we start from here, hop to this star and go all the way or do this hop like 5 more times. 1, 2, or 5. I find a star over here. This is not very bright star, but it is just a tiny little star right there. This star is the North Star. North Star is a great marker for north. Well, as you can see, without using electronic device or compass, I can just, by looking at the stars, tell you where is north. Well, this direction is north, and the North Star is the tail or starting point of the Little Dipper constellation. So do they look alike? Big Dipper and Little Dipper. Great. Also known as Ursa Major and Ursa Minor, which means big bear and little bear. I will leave it up to you how to imagine the bear part. But as you can see, I can just find the north direction without needing anything. And this is actually used by humans for a long time because they were able to travel around the world on ships without using any GPS or long before invention of GPS. They discovered the entire world, mapped it, discovered continents like the continent of America, right?
Yeah,
And
impressive.
they used stars as navigation. Of course, North Star is only used for finding north. Also, it can tell you the geographic latitude too, if you can measure how high the North Star is from the horizon. But this is how it is done. It is very easy. You can just navigate in dark using stars. It is called celestial navigation. It's an amazing technique, still actually taught courses in the military academies. Military is interested in these very well.
Yeah, we have one important thing that we
Yeah.
can't miss. That we cannot miss. We have a very interesting and fun conjunction coming up.
It is.
Yeah. So if we were to look to the north or the to the west, maybe northwest, we can start to see it already happening right now.
Okay, let's set up the sky for northwest and see that conjunction. It is happening next Monday, right?
I mean, yes, maybe the primary point is happening next Monday, but it's they're moving together already, so you can kind of see them together, and that I think that claims as a conjunction.
Yes. If anything, any two object is coming close to in the sky, we call it conjunction. Means like meeting. Two objects meet, and that happens all the time. If I'm not gonna be surprised if I see the headlines like, oh, this is rare event and happening in 1,000 years. No, the things happen all the time. But things like these happen all the time.
Definitely. So this is the sky tonight
Mhm.
at approximately 9 p.m. We're looking to the northwest. You can still see a bit of the Big Dipper right above your head there. And then you can see the two extremely bright objects just underneath me.
These are right.
Yes. And if you want to point those out, we can show them as the days pass what's going to happen with them. And then we have on Monday an exciting visitor. So this is kind of neat. This is why I thought it was super important to bring up.
So let's talk about what these are. These are the planets of our solar system.
Yeah, this is Venus, the brighter one.
Yes, Venus is always bright.
And then we have Mars just above it and to the left.
You can ask like the Mars and Venus. Those are both neighbors, right? So they are the closest planets to Earth. Why Venus is so bright and the Mars is tiny?
Because Venus is closer, much closer, and it's bigger.
That's right. But if you just think about it, the Venus is inner planet. When I see Venus, it will be always on the close side of Earth. Mars is outer planet. Because Mars is outer planet, if I'm seeing on the sun side, like there is the sun just set, the Mars is actually on the other side of the sun. So the Mars distance is actually doubled, more than doubled. So Mars is too far away right now in the orbital configuration with respect to Venus. Venus is at nearly the closest point.
It's definitely bright. So this is what the sky will look like on Monday. And you can see we have a third little visitor right underneath it, if you want to point that out.
Which is also the closest celestial object
to
Earth.
It's really hard to see if you're using a mobile device, but just to tell you, the moon is just beneath and a little farther north than these two star-like objects we know as Venus and Mars. And then the day after this, so on next Tuesday, the moon is going to get brighter, and then these objects start moving farther apart. So definitely why we need to bring it up today.
Yes. And also, we had a social media posting about aphelion being yesterday, right?
Yeah, we can talk about the aphelion.
All right, let's see if anybody knows what is aphelion is. Well, the helion is related to the sun.
If they just want, I mean, this could be a test. Did you guys look at our social media post yesterday?
I think we need to do a little quiz as part of this program and maybe offer some free tickets or freebies. Whoever knows. Okay, the distance of Earth to the sun. It's not a static distance or because the Earth orbits around the sun, and that orbit is not completely circular. There is a little it's a little elliptic orbit, not too compressed, but a little elliptic. When you look at it, look at the actual drawing, it looks like a circle, but it's not. So because it's not a circular orbit, that means the Earth is slightly getting closer to the sun and slightly getting away from the sun. So the distance is changing, and there's a small range for that change. When the Earth is in the closest position to the sun, we call it perihelion. When the Earth is at the farthest point to the sun on the orbit, we call it aphelion. So yesterday, right? Yeah, yesterday was the aphelion point. Still, we are actually pretty farther point from the sun. So here is the thing. How come the time is July and it's pretty hot in Texas? Not
We're
yet. Actually, we haven't seen
smashing
the
records all over the U.S. for temperature too.
exactly. So the temperatures are certainly rising, and it's pretty hot, right? And in the meantime, when the temperatures are getting hot, we are getting away from the sun. The distance increases, and yesterday we were at the farthest point. So
But it was summer, Levent. Why? Why doesn't that?
shouldn't it be that be opposite way? Shouldn't we just get close to the sun and feel the summer hot and get away from the sun and feel the winter cold? What's happening? What is going on over here?
I don't know.
All right, let's see if anybody can answer the question. What was the new for me to know what even the sun is not centered precisely in Earth orbit? Is it normal? Yes, Lamia, that's a great point. When the orbit is elliptical, the object is not the heavier object or dominant object is not going to sit at the center. There's actually the general rule is there is never
Ding,
one
ding,
object is at the
ding.
center and other object is around. Link to the angle to the rotation of Earth. That is the right answer. But let's not mix up
Huge.
the things.
Huge.
So
That was quick.
I was talking about, yeah, when there is two objects, this is called two-body problem, okay? According to Newton, the great physicist Newton, this is two-body problem. And the two-body problem is, well, the body is itself is not a problem. Don't get me wrong. We don't have any problem with the sun. We don't have any problem with the great planet Earth. When there are two body in space, within their gravity domain, two objects follow a path in the orbit, and the path is determined by their like the center mass. So the center of mass of this Earth and Sun system falls somewhere in the sun because the sun is dominant. A huge mass. For that reason, two objects is follow a path around the center of mass. So if the center of mass is over here, that means the Earth is orbiting not around the center of the sun, it is orbiting around the center of mass, slightly off-centered from the sun's center point. So obviously Earth is doing what it does, orbits around the sun, draws a big circle. In fact, it's an elliptical orbit, but the sun, because it also follows a path at the center of mass, which is slightly off-centered, so that makes the sun look like wobbling back and forth, back and forth.
This is how we find exoplanets sometimes, right?
That's correct. So because we know sun wobbles as planets orbit around it, the sun is not like a permanently centered object in the solar system and it wobbles. So as the increased precise detectors, we started looking at other stars and see if they are also wobbling. And when we detected their wobble, we confirmed planets around them. Isn't that cool?
I think so.
This is exactly how we work. The
It's such a
astronomers
simple thing to do something that feels so complicated.
Yeah, we cannot visually see the planets around other stars because they are too far away, too blended in, and it is just under the limits of the light that we can visually see them. So, but we can detect their wobble. There are, of course, other methods to find extrasolar planets orbiting around stars, but this is one of the methods. All right, so I was talking about the aphelion. Yeah, and Lamia said gratefully that the inclination of Earth's axis is causing all the seasons to change. And yes, how much heat we receive from the sun is not related with how close we are to the sun. It makes a little difference, but just a little difference. And I have a good actually analogy for this. For example, if you are familiar with the quartz heaters, the heaters with like the long just a line of like a pipe
Yeah.
or resistance at the center. So they are pretty like the radiating the heat in a focused way in the like the center direction. And if you are just sitting in the middle of the center line, you feel all the heat. And if you just get like a 1 foot on the side, then you are losing enormous amount of heat because you are just receiving the heat. If you are at the center, receiving the heat directly, and you are receiving the heat at an angle if you are just stepping aside. So it is the same way. During the sun, the sunlight is coming more direct way, or let's say centered way to the earth. And that makes the heat received by the earth maximized. In the wintertime, because of the inclined axis, the sun is appearing lower and lower in the sky. It's not like sunset, like at the high noon, at the noon time, we look at the sun's height. It's always higher in the summertime because sunlight is coming at a more direct angle. Well, in the winter time, at the noon time, the sun seems lower in the sky, and that means the sunlight is coming more angled. So this more angled, that means the more less heat received by the planet. So that affected the seasons. That's the main reason of the season. The distance has only little effect. All right, so Lamia also says, and great, she's the one telling all the facts today. It was interesting to know that it's winter in southern hemisphere, and that is right. So when we are feeling summer in the northern hemisphere, people in the southern hemisphere are feeling winter. And the opposite way when we are in the
That is definitely wild to imagine, but yeah, very interesting. Thank you so much, Livia, for your interactions
exactly
today. Very grateful.
All right, so you showed me a plane picture, and I think you have an update from the space tourism or travel.
Yeah, we're definitely running extremely long on time right now, so I won't keep them too much. But we do have one thing to mention. We can. I have a little bit of a story, an important thing I wanted to get to today, but we'll push it off till next week, which is just more content. Um. Anyway, yeah, definitely. We had some interesting stuff we talked about last week, I think, which was is Richard Branson and Virgin Galactic going to go to space before Jeff Bezos, who we are all pretty sure was going to? Last minute, hey, we got accepted by the FAA, and the answer, unless there's some cancellation due to weather or other issues, is yes. Richard Branson is gonna beat Jeff Bezos to space tourism, and it's kind of crazy. The idea of what they do is so complicated, and to get to space with Virgin Galactic, but at the same time, I think a lot of people agree that it seems a little safer, a little more like tested, which is, hey, we can just use a plane, get a plane really high in the air, and then launch a rocket off the plane, and it'll go the rest of the way, and they'll be in space, and then they'll glide back down to safety on Earth. Um, Rather than, I'm gonna just create one gigantic explosion and aim that explosion straight to space, which is what most space capsules, Apollo capsule, and Jeff Bezos is trying to do. Um, pretty fantastic. There's so much involved with this plane. Just to kind of go through it. So the way they get to space is they take this it's like two planes combined into one, and it has two pilots, and this plane flies up in the air carrying, as you can see right in the center here, the passenger plane is carried in the center, and it has you can see the back end of the rocket engine there that blasts it. It gets about 50,000 feet in the air. It drops the small plane, and the small plane will just blast off and get to the other 100,000 feet to get the rest of the way up there.
So that's very interesting design. So like all the spacecraft we launched, which are the modular pieces.
Mm-hmm.
So this space vehicle system goes in the air, and then this is the final part that makes it to the space.
Yep. This part launches off, it blasts off to outer space, and it gets to the edge. I think they get to what's called the Kármán line. I'm sure I'm pronouncing that wrong, but and it's just where they say this is basically space.
So, does that plane land itself? Does it have a landing
Yeah.
gear?
It gets back to Earth and it glides down and lands at the picture we just saw, which is Spaceport America in New Mexico.
Pretty interesting.
Yeah, it's I mean it's tried and true method. So it just seemed like we fly planes all the time, and somebody who owns a plane company was like, I could just use a plane to take another plane to space. The scary part is that the people inside of the one in the center right here. So if I just bring this picture back, this is called VSS Unity, which stands for Virgin Spaceship Unity. So it's called Unity. This carries the passengers. It's a super luxury plane designed for people with these windows on top to just be able to see the Earth from outer space. That's the whole purpose in it. This plane hits Mach 3 on the way up and Mach 3 on the way back down. And you only get a few minutes of weightlessness. So that's scary. Mach 3 is...
So does it go to the 50,000 feet?
No, the two twin engine, one goes to 50,000 feet. So this big plane goes to 50,000 feet. And then at 50,000 feet, the smaller Unity spacecraft, or they call it Spaceship 2, he separates, fires its rocket engine, and accelerates to Mach 3 before reaching the 300,000 foot mark. And that's when it's in space at that point. They get a few minutes of weightlessness and then incredible views of the Earth. And then it comes back down.
I mean, technically, it is still considered in the atmosphere.
Oh, yeah.
But the atmosphere is pretty thin and not thick enough to provide blue night sky. You can certainly see through at that level.
Yep. This is just the plane, by the way. This is just
amazing. I mean, it is not technically in space, but I think it will just give the feeling of being in space.
They say that the Kármán line is where they say you are in space. I mean, but it's all arbitrary, right?
Mean, still, you will be bound by the Earth's gravity.
Yeah.
You will not float.
I mean, in a way, you're never not bound by the Earth's gravity. You're always pulling on you. Anyway, it's cool. It's a neat ship. This is called VMS Eve, and Richard Branson apparently named this after his mom. This is so wild. I don't know if you can point to it, Levent, but there's a picture of a woman right here. This is Richard Branson, the owner of Virgin Galactic, painted a picture of his mom on the spaceship, and then named the spaceship, which is not really a spaceship, it's just a plane. It's called Mothership. So it was really, the whole thing was kind of funny. Named it after his mom, painted his mom on it, and then called it Mothership. Certainly an interesting guy. Anyway, bunch of launches this month, a whole bunch of things that we get to talk about next week, and yeah.
In the meantime, if you have any questions or interesting topics that you would like us to address, please let us know. We'll be here and see you next week.
Yep. See you, everybody.